going to kind of continue here for the last 20 minutes of class with 7.1. You've seen the content or the conceptual piece of this, though, on where this integration by parts is coming from. All that we're going to do now is just run through some more examples of using this and like looking at difficulties that might come up. That first example was like the simplest, like a very simple situation or a simple case. So if we look at the next one, this is the integral of the natural log of x. Remember that we don't have a antiderivative rule for the natural log, right? We know the antiderivative of 1 over x is the natural log, but we don't have an integration rule for the antiderivative rule for natural log. So let's try doing this by parts. So what should I pick as u and what should I pick as dv? I definitely don't want to pick natural log x as dv because it's going to be the same problem that I have currently, right? So natural log x certainly would have to be u. What's that leave for dv then? Just the dx. Everybody's okay there? So if I then differentiate, du dx is 1 over x. So du is 1 over x dx. And if I integrate, what's the integral of dx? Well, you can think about it as 1 dx. So so it's just x, right? Does everybody feel okay there? So then we just, into the formula we go. So we have u times v minus the integral of v du. Everybody's okay? What do I notice here? So again, what's the integral of 1 dx? Just x. And then I'll tack the plus c on at the end, and we're done. Everybody feel okay? So far, so good? Okay. Let's look at the next one here. So again, we're going to start by choosing our u and our dv. So which one should I pick for u, t squared or e to the t? I'd want to pick t squared because when I differentiate that, I get a simpler polynomial, right? It becomes a degree 1 polynomial as opposed to degree 2. What happens if I differentiate the exponential? Stays the same. That seems like a crummy choice for you if it doesn't change at all. And what's lovely about integrating an exponential? It's just the same thing, right? Ooh. So we'll do that. So du is just going to be 2t dt. And v is just going to be e to the t. Everybody's okay with me not writing a bunch down for those ones? They were pretty simple derivatives and integrals to do. And now that we've seen a couple of examples, I'm going to kind of compress a little bit of the work here and there. So again, my integral is going to be u times v minus the integral of v du. What are we going to do with this? Well, u sub's not going to work on it because I still have that t, right? I just have to do another integration by parts. It got simpler than the previous integral because it's a degree 1 polynomial times an exponential instead of a degree 2. But just looks like another integration by parts problem to me. So the u I'll pick to be 2t. So du is going to equal 2 dx, or I'm sorry, dt. dv will still be e to the t. So v is still e to the t. So we have then t squared e to the t minus, I'll have u times v minus the integral of v du. And now that integral that I'm left with is certainly doable for us, right? What's the integral of 2e to the t? Still just 2e to the t, right? Does that feel okay? Does that happen a lot, you think, where you have to do 2 successive by parts? Not usually, right? The place where I would be on the look for having to do multiple integration by parts is when you have something like this where you have a polynomial times an exponential. Oftentimes, like, the degree of the polynomial will tell you how many parts, integration by parts, you'll have to do. Where this is a degree 2, so I needed 2 integration by parts. All right. Next one. We have e to the x times sine x. Which one should I pick for u and which one should I pick for dv? Do either of them really get simpler when I differentiate? Not really. So maybe instead I pick okay. So let's do which one do we want to try where? What do you guys think here? Which one? Anybody got an idea? Any instinct? What should be my u? What should be my dv? You want to do u as sine x, huh? Okay, let's try. Okay, so the derivative of sine x is cos x, and the integral of e to the x is just e to the x. So let's see what we get. So I'm going to have u times v minus the integral of v du. All right. That didn't seem like it helped me out a whole lot. But we just saw in the previous problem that maybe I have to do this again. So maybe I just try it again, right? So when I do my parts a second time, I have u times v minus the integral of v du. And yuck, what just happened here? What? Did you guys see what happened? What, do you recognize this? So we started with. So if I like subtracted that from both sides, because it's all still one equation, that's not going to work, right?
So you're just going in a circle, kind of?
Well, it kind of seemed that way. What I really would have wanted to do, to me, what it looks like is if I would have done the reverse and made this e to the x and this one sine x, what would have happened is I would have had a minus here where I could add it back over to the other side and then divide by 2. And then I'd have an expression with no integral in it on the right-hand side. So we just picked the wrong ones. The one where it's ambiguous like this, where it's unclear which one should be u and dv, when neither expression gets simpler to integrate, sometimes it's a little bit of a coin flip, and you pick wrong, and you get to it's like that didn't get me anywhere. So let's try it, doing it the other way, so you can see it work out. So we have a minute. So we'd have then u times v minus the integral of v du, or I'm sorry, dx. And then again here we'll do our parts again. Oops. I'm trying to do it wrong again. Okay. we have u times v minus the integral of v du. And here, if I distribute the negative through, that's negative. And then there's 1, 2, 3 negatives there, so that's just going to stay negative. So I can add this guy back to the original starting side. And when I do that, I'm going to have 2 integrals e to the x sine x dx equals this stuff. And then I just divide both sides by 2, and there's my answer. That's also an uncommon occurrence when you have to do something like that, but it happens. What do you suppose we do if we have a definite integral? It's the same thing, right? You can evaluate the uv piece, and then the bounds come with you to the second integral. I think we're almost out of time, so I'm not going to go through and do the specific example. But that's the gist of it. We're not going to prove that. I'm just going to ask you to do 3 through 17 odd from this section. Just do a little bit of practice here. Everybody feel okay? I want to point out to you also that as we spoke about last time, I did put up some homework quiz stuff onto the MyAP for the Chapter 9 and Chapter 7 stuff. Even if we haven't covered the Chapter 7 stuff, all of it, I think I put the thingy-jiggers in there for it. I think I have everything that we're going to do homework quiz-wise now up in there. So as you kind of get through the homeworks, take a minute and do the homework quiz from the equivalent section. Next week we'll do like what are we gonna we're gonna do the trigonometric substitutions and the improper integrals, and those will be like, we'll circle back and do one more differential equation section after that, but that'll be the content, like 3 more days of lessons will be the content for the year. That's not too bad. Still kind of toying around with what the test format's going to look like, but it may be something a little bit different than what we've been doing to make it a little bit more user-friendly to you guys. So as I'm kind of playing around with that, and once I've got that figured out, I'll let you guys know. What do you think? Yeah? Whatever? Whatevs. Okay. Okay. Well, that's kind of wraps for me. How are you guys feeling overall, other than like burnt out and stressed out? It's good. How's the start of the spring athletic season going? Hectic? Mm-hmm. Okay. I don't know, this is just me checking in on you guys,